All right, welcome to The Explainer. Today we're diving into something that has totally reshaped our digital world, natural language processing, or NLP. And specifically, we're going to talk about a revolutionary moment in 2017 that taught machines to understand language in a way we never thought possible.
You know, you might not even realize it, but you're using NLP all the time. Seriously, it's like this silent partner that's running in the background of so many things you do online every single day. So, let's take a closer look.
Think about it. It's the magic that powers that Google search you just did. It's the chatbot that answered your question on a website at 2 in the morning. And it's definitely how your favorite streaming service seems to know exactly what movie you're in the mood for next. It's literally everywhere.
Here's the thing. Even with all the power of deep learning, there was still this one major hurdle, this one problem that kept tripping up all the models. The solution, which came out in a single, now famous paper in 2017, was an absolute breakthrough.
And what was that huge challenge? It all boils down to one word: context. How on earth do you teach a machine that a word's meaning isn't fixed, that it can change completely depending on the words surrounding it?
Okay, check this out. Just look at these two sentences. They are almost identical, but one little word changes everything, especially the meaning of the word it. Right, so in sentence A, it is obviously the horse, no question. In sentence B, it is just as obviously the street. You and I, we get this in a split second. But for a machine, trying to figure out that relationship, that was incredibly difficult. And then came that 2017 paper from Google. It introduced something called the transformer architecture. And its secret weapon, its secret sauce, was this brilliant new mechanism called self-attention. So, with self-attention, a transformer can look at a whole sentence at once, like, I arrived at the bank after crossing the river, and it instantly knows that bank means a riverbank, not a place you put money. It does this by figuring out which words are most important to each other. It creates this direct link between bank and river. It just gets the context, which is absolutely amazing.
And get this new way of doing things wasn't just more accurate than the old models like RNNs, it was also way more efficient. See, the old models had to read a sentence one word at a time, in order. But transformers, they could process all the words at the same time in parallel. That slashed training time and the amount of computation needed. It was a total game changer.
So the transformer didn't just solve a problem, it basically laid down a whole new foundation. And researchers immediately started building incredible new things on top of it.
Almost overnight, we started seeing innovations like Transformer XL, which found a clever way for the model to remember context from way longer pieces of text. We're talking whole articles, not just sentences. And then came things like the Reformer, which pushed efficiency even further, letting these giant models run faster with less memory. The revolution was just picking up speed.
So, if we pop the hood and look inside, what does it actually take to make any of this modern NLP stuff work? Well, it really all comes down to two key things: getting your data ready and then using the right algorithms to process it. First off, you can't just feed raw, messy internet text into a model. It has to be cleaned up and standardized. That means making everything lowercase, stripping out weird characters or code, getting rid of common words like a and the that don't add a lot of meaning, and boiling words down to their root form. It's all essential prep work. And second, you've got this whole toolkit of algorithms to turn that clean text into numbers a machine can crunch. It ranges from older methods like bag of words, which basically just counts words, all the way to these incredibly powerful models like word2vec and glove, which can represent words as vectors and capture all the subtle relationships between them. You know, what's really at the heart of all these advanced techniques is one beautifully simple idea. You can know a word by the company it keeps. In other words, if two words tend to show up in the same kinds of sentences, they probably have similar meanings. That idea is the absolute bedrock of modern NLP. So when you step back and look at the whole journey, from manually crafting simple rules to building these massive architectures that can actually grasp context, the progress in NLP has been nothing short of a revolution. It's completely changed how we interact with technology, and it leaves us with this really fascinating question to ponder about the future of conversation itself.
So where's this from? It's all coming from the channel Learn with Praveen.